Imagine stepping outside on a bright morning and seeing a horizon that never curves, no matter how high you climb. Oceans stretch endlessly without bending, and when ships sail away they never disappear hull first. Airplanes follow straight paths above an infinite plane. In this alternate reality, Earth isn't a sphere at all, it's a colossal, flat expanse. What would life really be like if our planet were flat? On a spherical Earth, gravity pulls everything toward the center of mass, giving us the feeling of down, no matter where we stand. A flat world changes the rules. If gravity still pulled toward a single central point beneath the disk, objects farther from that center would feel a sideways tug. Rivers would curve inward, oceans would slosh toward the middle, and anyone living near the edges would feel like they were walking uphill. To keep things feeling normal, gravity would have to act differently, perhaps pulling straight down everywhere, which violates the physics we observe. That means either new, exotic laws of gravity or some other force we've never discovered. Everyday experiences like dropping a ball or pouring a drink would reveal the difference immediately. Our 24-hour day comes from a sphere spinning on its axis while orbiting the sun. On a flat Earth, creating night and day would be tricky. The sun could no longer shine evenly across the surface while setting beyond the horizon. To have daylight and darkness, the sun would need to hover like a spotlight, circling above the disk. But a close, circling sun would look very different from the one we know. People near the center of the disk would see it take smaller, tighter paths overhead, while those toward the rim would watch it travel huge circles, changing size dramatically through the seasons. Long-distance travel or simple astronomical observations would expose the strange geometry. Our winds, storms, and ocean currents are driven by a spinning sphere. The Coriolis effect sends hurricanes twisting and helps distribute heat. A flat, non-rotating plane would lose that balance. Without global circulation, climates would become extreme. The center of the disk might swelter under constant sun, while the outer regions could freeze in eternal cold. Oceans would also behave oddly. If gravity pulled toward the center, all water would slide inward, leaving the rim high and dry. A single enormous, world ocean would dominate the middle, with vast deserts around the edges. In our real universe, satellites orbit because of the planet's mass and curvature. On a flat Earth, stable orbits wouldn't exist the same way. GPS, weather satellites, and space travel as we know them would be impossible. The moon would present another mystery. Its phases, eclipses, and tides all depend on three-dimensional orbital mechanics. To keep tides and lunar cycles, the moon would need an entirely new set of physical laws, something no telescope could hide. Human history would be different from the start. Ancient sailors would never watch ships disappear hull first. Explorers wouldn't circle the globe, they'd chart an endless plain. Trade routes, navigation, and even our sense of global community would follow different logic. Perhaps people would build cities toward the center, where gravity and climate are mild, leaving the edges sparsely populated or surrounded by giant mountains or ice walls to contain the atmosphere. Legends would flourish about what lies at the rim: endless sea, sheer cliffs, or a mysterious boundary. A flat world would demand a completely different cosmos. The stars we see today rise and set because Earth rotates. Their patterns shift with our orbit around the sun. On a disk, we'd need an elaborate cosmic mechanism to explain those same observations, one that somehow mimics the precise motions we actually measure with telescopes and physics. Imagining a flat Earth isn't just a curiosity, it highlights how the planet's roundness shapes everything: gravity, time, weather, and even our understanding of the universe. The everyday facts that keep life possible, air pressure, stable climates, predictable seasons, are all products of a spherical world held together by gravity and orbital motion. So if Earth were truly flat, the sky would behave strangely. The oceans would pile toward the center, and the laws of physics as we know them would need a total rewrite. Our real, round planet may feel ordinary, but its shape is the quiet engine behind every sunrise, every tide, and every breath of wind that makes life possible.